The focus of this video is on the performance cache and DRAM blocks. Now within VisualSim Architect we have two categories of these kinds of blocks. The first category is the performance models of the cache and DRAM, and the second category are the more detailed cycle accurate models. And in this video we are going to be focusing on the first category of performance models. Now consider the following block diagram. The blocks on the left hand side are responsible for generating the task, and inside of the task are a series of instructions according to the target processor that will be simulated on the processor itself. During the simulation of these instructions there will be a set of memory references that will be generated, and those memory references will be sent to the cache model, and if the cache model results in a cache miss, it will be sent to the DRAM, and once that is done it will be returned to the processor, which will allow it to continue executing the instructions. Now the cache model is a performance model of the cache, and the block parameters for the cache model include the miss memory name, which means that if there is a cache miss, you need to specify which memory it needs to be sent to, the cache speed, and importantly for this performance model, the cache hit expression. Now in the performance model of the cache, we are not modeling the individual lines of cache. What we are doing instead is modeling the cache hit ratio in the form of a uniform distribution, and that relationship to a probability number. And what happens is that a uniform distribution, uniform random number will be generated upon the transaction or memory reference arriving at the cache, and if that uniformly distributed number is less than the probability, that will result in a cache hit, and if it is greater than that number, it will result in a cache miss. If there is a cache miss, the memory reference will be sent back over the bus to the DRAM model, and the DRAM model, its block parameters include things like the memory speed, the size of the memory, as well as the access times. For example, a read access time would be 5.0 divided by the memory speed. If you're doing a prefetch, then it will be 6.0 divided by the memory speed, and so on. So what will happen is this. Let us assume a memory reference is generated by the processor. The memory reference will be encapsulated in a transaction. The transaction will be sent over the AHB bus, and it will be sent then to the cache. If the cache model and the uniform distributed number that's generated is less than or equal to the total probability for a cache hit, then the cache will return the transaction back to the processor. Now, on the other hand, it results in a cache miss, namely the uniform number is, randomly generated number is greater than the overall probability of a cache hit. Then the transaction will be sent back over the bus and sent to DRAM, where it will be serviced by the DRAM. Now, of course, the amount of time that it takes excuse me, for the transaction to be fulfilled from the processor will depend upon whether it's a cache hit or miss. If it's a cache hit, it will return faster. If it is a cache miss, it will have to do additional operations of going back over the bus to the DRAM and then back through the bus back to the processor. These performance models are very powerful for defining and evaluating initial hardware topology. And once you have converged to an optimal topology, and if it is desired, then you can replace these performance models with the cycle accurate models to get more detailed overall understanding of the system. This concludes this video on the performance cache and DRAM blocks.